Hello everyone, welcome back to our course. Next, we are going to introduce Cassandra, which is a famous column-based database. Maybe some of you have heard about Cassandra before. In fact, Cassandra's name is derived from Greek mythology and is the name of a tragic prophetess in Troy. So, the project's logo is a shining eye. Here we say Cassandra is highly reliable, large-scale distributed storage system. It is highly scalable, consistent, and distributed structured key-value storage solution that integrates the data model of Google Bigtable and the fully distributed architecture of Amazon Domino. We emphasize that Cassandra uses the data model of Google Bigtable. Actually, both Cassandra and HBase are developed based on a paper called Bigtable issued by Google, and slightly later we will draw a simple comparison between them. And derived from Google Bigtable, both HBase and Cassandra are column-oriented databases, which is different from most traditional row-oriented relation databases. Besides, columns in Cassandra are organized into column families. So what is row-oriented and column-oriented? Here you can find a graph showing the difference. Literally, in row-based storage scheme, data are written in rows, and each row is the basic logical storage unit. One row is a continuous entity, while different rows are separated in the disks. For example, suppose we have a table of staff information. Each row has fixed structure and is related to the information of the same person. Then we can easily write or read data of the same person row by row. However, if we need to analyze the details of a certain column, for example, how many people are from China, how many people are from France, then what can we do? Because each row is a continuous entirety, we cannot make jumps between different rows, but to scan all the data row by row. So we have to read many unnecessary information. This is very inefficient, especially if there are millions of columns, but we only need several of them. So we need column-based storage systems now. Now, each column rather than each row is a continuous entirety in the disks. And thus, we could only read or write by columns now. Column-based storage is designed to satisfy the increasing demanding of column-based analysis. And a column-based analysis means that we analyze data from the same column. Therefore, we can draw a brief conclusion. The column-based storage system is very suitable for reading and analyzing, but when a row is read, we need multiple I/O operations. And actually, both storage systems exist in industry and they are popular for different kinds of tasks. And please remember, the Cassandra is a kind of column-based storage component. Now, let's take a look at the basic data structure in Cassandra. In Cassandra, the data model consists of key spaces, column families, primary key, and columns. The following table lists the data models of Cassandra compared with RDB. The key spaces in Cassandra are very much like the database in RDB, which serve as the namespaces for tables. And in RDB, we store data in tables, while in Cassandra, we store data in column families. But both have primary keys for indexing and indicating uniqueness. In RDB, we have columns with their own column names, while in Cassandra, there are also columns with keys or column names. And finally, there are column values in Cassandra as well. Moreover, in RDB, we can use SQL statements to do queries and data analysis, while in Cassandra there is CQL, which stands for Cassandra Query Language. Again, Cassandra uses CQL to create commands that work with its schema, structure, and data. But CQL is totally different from SQL because Cassandra is still a NoSQL database. And to give you better understanding of Cassandra, we prepared the Cassandra architecture. Like in many different distributed systems, Cassandra has a computer cluster with many servers. And it distributes data into different nodes. Here we say each node is a server where data is stored. It is the fundamental infrastructure of Cassandra. And many nodes together is called a data center. Namely, a data center in Cassandra is actually a collection of associated nodes. And then many data centers together is called a Cassandra cluster. That is, a cluster contains one or more data centers. As is shown in the right figure, there are nodes for data storage, and associated nodes make up the data centers. And many data centers make up the entire cluster. Besides, in Cassandra, data is kept in the memory for highest efficiency. But we know that data stored in memory is vulnerable. Therefore, we can use a commit log to record all the writing data, and thus we can ensure persistence. As for SS table, it stands for sorted string table, which is an immutable data file written by Cassandra into mem table periodically. Simply speaking, it is the data stored in memory. And for CQL table, it is just a sequenced set extracted from table rows. This table consists of columns and has primary keys. So we know that Cassandra is widely used in real industry. Then what are the advantages or features of Cassandra? Here we listed several of them. Firstly, massive scalable storage. Cassandra can scale to hundreds of terabytes and runs on commercial clusters with outstanding performance. Secondly, easy to manage. Cassandra clusters are easy to manage on a large scale and can be dynamically expanded as requirements change. Thirdly, high availability. Cassandra is designed to be always on and has supported features such as zero downtime upgrades and has been used in production environments for more than a decade. Fourthly, write-intensive applications. Cassandra is especially suitable for time series data in write-intensive applications, such as time series stream data, sensor log data, and IoT applications. Fifthly, statistics and analysis. Cassandra can be integrated with big data computing frameworks such as Spark. Users can use the powerful memory analysis function of Spark to perform big data statistics and analysis. Sixthly, multi-site high availability. Cassandra supports remote multiple data centers. Data can be replicated and backed up across multiple clouds and data centers. And just as we mentioned before, both Cassandra and HBase are developed based on the same idea. Plus, both of them are popular in industry. So it is natural to draw a comparison between them. Here we say Hadoop HBase also uses the column family model, so the core idea is just the same. But the differences are listed below. Firstly, Cassandra has only one type of node, whereas HBase has multiple rows and is based on the Hadoop bottom layer platform. Therefore, Cassandra deployment is easier but HBase is more stable. Secondly, the Cassandra data consistency policy is configurable, while HBase loses overall consistency policy in many cases. Thirdly, HBase provides a row log mechanism that Cassandra does not have. To use the log, Cassandra needs to cooperate with other systems, such as Hadoop Zookeeper. Fourthly, HBase provides better MapReduce parallel computing support. Cassandra 0.6 also provides this function. Fifthly, Cassandra has better read and write performance and scalability, but is not good at interval scanning. Finally, we can conclude this chapter by introducing the application scenarios of Cassandra. As mentioned before, Cassandra is very good at risk control and personalized recommendation scenarios because it is column-based and has a very high accessing efficiency. Besides, in social networking scenarios, Huawei introduced a cloud service called GaussDB for Cassandra. This is often used to store operations such as following, posting, and likes. Smooth and elastic scaling can quickly cope with the traffic impact of social hotspots. So in short, Cassandra is also a good choice for social network data storage and analysis. Alright, that's all for this chapter. In this chapter, we introduced what is Cassandra, some basic data models of Cassandra, a little bit about the CQL language, the Cassandra architecture, some features of Cassandra, and comparison between Cassandra and HBase. Hope you guys enjoyed all the contents in this chapter, and see you in the next chapter.